Hello everyone, welcome to Deeper Bits. My name is Rohit Raj. In this video, we are going to cover intuition behind version control system. So I think before learning a tool, it's very important that we should understand the concept behind it. So I just want to ask a question with you guys. What do you think? What is exactly a version control system? So when we see this word version control system, so from this word it looks like we are talking about a system which is able to manage code slash work. So what I meant about it is, let's say we have code, and with this system we are able to maintain the versions of that code, and let's say in any version there is some problem, so as a safety net we can roll back to the previous version, right? So let us think about it, like how we can really design it. So let's say we have v1.txt. In this file, what we did is we have saved our content, and now we want to create the another version. So what we can do is we can copy this file, and then we make the changes, and after that we save it as v2.txt. So yeah, now let's say I want to create more versions. So what I did is I have copied v2.txt, I have made changes and save it as v3.txt. And similarly we can make many versions. So let's say we have made versions till v6. So now we have from v1.txt to v6.txt. Yeah, it really looks simple, right? We are able to design our version control system. But I think there is actually one problem. So what is the problem here? Let's think about it. So let's say your file v1.txt is a very big file. Let's say it is of 1 GB, right? Now, when you created the second file, what you did is you made the copy of this file, and let's say you have made some changes in KBs. Let's say you have made a 4 or 5 KB change, right? And now you save this whole file. So this whole file is also approximately 1 GB, because 4 or 5 KB is negligible, right? And similarly we created one another version. So we have copied this v2.txt, which is a very big file, made some small changes and then save it again. So now we have v3.txt, which is also of 1 GB. So now for 6 versions, basically what we have is our one file is of 1 GB. So 1 GB into 6, that is basically 6 GB. Oh, that doesn't seem so very huge, right? Now let's think, let's say we have 1000 versions. Let us see our problem in a scale. So for this 1000 version, if every file is of 1 GB and we are making changes in KB, so let's neglect that, right? So the total number of the files we have is 1000, and the total storage that we incur is 1000 into 1, that is 1000 GB, that is 1 TB. So that is really huge. Like in your computer, if you have 512 GB of RAM, you will totally run out of space. So this is very inefficient design. Okay, so what we can do it, so let's optimize our design little bit. So now what, let's tweak our design little bit. So what we will do is, now we have v1.txt, and we are designing our version control system, and now let make it a little bit more smarter. So now you create v2.txt, you have make some changes, and you set your version control system to save it. So instead of saving the whole file, what it will do is it will try to save only the delta, I mean the difference between v1.txt comma v2.txt. So it just save the delta between those two files. Now let's say you have created the another version v3.txt, and then you tell your version control system to save it. Now your version control system is little bit smarter. So what it will do is it will just save the difference between v2.txt comma v3.txt as a v3 behind the scenes. Now similarly it is just saving the delta, and we call it as v4, v5, v6, right? So now when we calculate the disk space, now what will happen is, let's say our first base file is of 1 GB, and every time we are making a change of, let's say, 10 KB. I just want to tell you guys, like, it's not always 10 KB. I am just assuming it for my calculation. In different cases it will be different, right? Let's see our calculation. So our first file is of 1 GB, and now our 5 file is of 10 KB each. And then when we calculate it, it will become 1 GB plus 10 KB into 5, that is 1.00005 GB. So yeah, Actually, we have solved our problem of disk space. Like if our version control system use the delta only, then we will able to solve this disk problem. So yeah, we are able to design our version control system. What do you think? But now when I'm thinking about it, I am realizing one more problem. So what is the problem here? So let's say in your version control system you have version till v6 and you have to calculate the version v5. So what you will do is you will take the base file, that is v1.txt, and then you will merge v2. V2 is what? V2 is basically the delta between v1.txt comma v2.txt. I mean the difference between v1.txt comma v2.txt. So then that's why we are calling it as v2, and you can see in my screen it is appearing as a green icon. So it is just the delta, right? So what we will do is we'll take the base file and then we'll merge the delta v2. Then what we will do is we'll merge the v3, which is the delta of v2.txt comma v3.txt. Then again we'll merge till v5, and now we will get our v5.txt. So this looks right? I mean, for 5 versions what we did is just we take the base file and we started merging the delta that is saved by our version control system behind the scenes when we have saved the version, and we are able to get our v5.txt. That's fine. Now let's see it at scale. Let's say you have 1000 versions and you want to calculate v999 version. So what you will do is you will take the base file, that is basically v1.txt, and what you will do is you will start merging v2, which is the delta, then v3, v4, v5 till v99. So here what you have to did is you have to did exactly 998 times the merging operation. So that is really very hard. In real case scenarios, if you are going to do so, it is really very hard and it will become a computing problem. So merging things n times is really very hard. Here what you did is, with this idea you have created a CPU and memory bottleneck, right? And in our first idea we have created a disk storage bottleneck. Okay, so what we can do, how we can solve this problem? So I have actually one more idea. What I think is, let's do this way. Let's take our v1.txt. For the v2.txt, what we will do is we'll tell our version control system to compress this file and then store it instead of just storing. Now what our version control system is doing is, we have v1.txt, we have copied this file, we have made changes, and we tell our version control system to make the version, and it has saved this file in a compressed manner, that is v2.txt, which is basically a compressed file. Then we create another version, and similarly we can create another versions, and behind the scenes it is stored as compressed files. Let's say we are at v6 and we want to go back to v5, then we will ask our version control system. Version control system already has the file in compressed manner, it will uncompress it and show it to you. Yeah, really looks simple, right? And in this way, let's say you have a txt file which is of 1 GB. With a good compressing algorithm, you can compress it to 50 MB to 80 MB. So if we calculate the size, then our base file is of 1 GB plus 50 MB into 5 times. I am taking the lower bound of it, and then basically our whole size will become 1.25 GB. Yeah, really good, right? So if we just store the file in a compressed manner, it will work and we will not incur too much of storage as well, right? But now when I think about it, I don't think like compressing algorithm works like in very efficient way when you want to compress any video or audio or PDF. So basically you can't guarantee how much it will compress. Let's say for video, audio or PDF, it is able to compress less than 5% or less than 1%. So if you are creating the versions where you are basically using images and you are doing some changes in those images and then creating those versions, so this compressing algorithm will not work efficiently, and then we will again run out of disk space. So now I want to summarize all these things. So what I want to tell is, the first idea where we come up with a very simple and naive idea of just storing the versions. If we'll do that, we will basically run out of disk space. So yeah, that's really very inefficient. Now with our second idea, what we try to do is, instead of storing the file, we try to store the delta. But then we have come up with a problem of memory and CPU problem, because it is computationally very hard to do merging operations when we are talking about 1000 versions or 10,000 versions, because we have to do, let's say, we have to calculate a 10,000 version, then we have to do merging operation 9,999 times. So it's very hard, right? So in second scenario, we run out with a problem of CPU and memory, and basically a computing problem. Then in the third case, we are able to optimize the storage, but it will not work always. Like, it will depend upon the type of the file you are using. If there are some files which will not able to compress much, then again you will run out of disk space. So what we are going to do is, in the next video we are going to take these three ideas, and then we'll going to come up with a very efficient solution, like how we can use these three ideas and come up with a efficient solution, so that our version control system uh, works in every scenario, so that it will not face any disks issue or memory issue or CPU issue, and it will work on every type of file, right? So that's all for today. And I just want to tell you guys, like, if you are facing issue to understand anything, you can revisit my video again. And uh, thank you so much. If you are really liking my content, and if you are really liking my video, you can subscribe to my channel. You can follow me on Insta and Twitter for more updates frequently. Thank you so much for your precious time here. Thanks again.